We don't just naturally start with these hypotheses. Where we actually start is with a claim, and so we need to look at how we take a claim and translate that into how we construct these two hypotheses. So if we have a claim, or once we state a claim, we want to express that claim in symbolic form. We need to write the statement that must be true when the claim is false. We refer to that as the negation of the claim. So essentially we're writing the opposite statement. The alternative hypothesis, as we've already seen, will be the statement with no equality. And the null hypothesis, H sub 0, will be the statement with equality. And we may have one additional step in there where, depending on the statement, we rewrite it as a strictly equal to statement. In example 4, we want to write the appropriate hypotheses to test the following claim. The average number of kids in a particular city who play basketball for a school team is less than 371. We'll start by taking that claim and translating it into symbolic form. We're talking about the average, so mu is less than 371. We're picking up on those few pieces of information to translate this into symbolic form. The negation of the claim, the statement that would have to be true if that's false, is that mu is actually greater than or equal to 371. These two statements are opposites of each other. They can't both be true at the same time. For the alternative hypothesis, we take the statement that is a strict inequality, which in this case is that mu is less than 371. So the claim became the alternative hypothesis. The other statement becomes our null hypothesis. But since we have this greater than or equal to statement, we'll go ahead and rewrite that as simply mu equal to 371. So we took the statement with some equality portion, greater than or equal to, made that the null hypothesis, but then just replaced it simply with an equal sign. In example 5, our claim is that the median number, so we're talking about the median, of kids in a particular city who play basketball for a school team is greater than 458. Our claim in this case is about the population median, so we use that symbol eta, which is greater than 458. Its negation would be that eta is less than or equal to 458. So for the alternative hypothesis, we choose the claim, which is that strict inequality statement. And for the null hypothesis, we take the negation, the statement that has some equality in this case, and we translate it into a statement with just an equal sign. In each of these cases, the claim became the alternative hypothesis. But that's not necessarily always the case. It will be one more time in example 6, but then we'll see some cases where that's not true. In example 6, the percentage, so we're dealing with a population proportion, of kids who play for a school sports team is different than 64.28%. Different than would be the same thing as saying P is not equal to 0.6428. The negation there would be P is equal to 0.6428. So our alternative hypothesis becomes the statement with a strict inequality. And our null hypothesis is the statement with some equality, which in this case is already exactly equal to 0.6428. Again, the claim became the alternative hypothesis, but in the next two cases, that won't be true. In example 7, the claim is that the average, so the mean, number of kids in a particular city who play basketball for a school team is at least 333. So the claim would be that mu is at least, so greater than or equal to 333, and the negation of that would be mu is less than 333. For our alternative hypothesis, we choose the statement that has a strict inequality. So that will be mu is less than 333. And the null hypothesis will be the statement with equivalence, which will translate into just an equal sign. So in this case, the claim actually corresponds to the null hypothesis. And we'll see that happen again in example 8, where we're told the percentage of kids, so the proportion, who play for a school sports team is at most 78.98%, meaning the claim is that P is less than or equal to 0.7898. The negation of that would be P being greater than that value. Our alternative hypothesis is always the statement with the strict inequality. And our null hypothesis will be, in this case, the claim rewritten with an equal sign. And again, we see the claim corresponding to the null hypothesis. So it will occur often that the claim ends up matching the alternative hypothesis, but sometimes the claim corresponds to the null hypothesis, and it'll be important to pay attention to that when we get to writing our conclusions.